My name is Kevin Basham, and this is my demo for Project 1 in CECS 447. This is the project that I started in the Texasware R2R, 3-bit R2R setup in order to get a starting location. Since then, I have sort of Googled how to use 4x4 matrix, as well as utilizing the Valvano website, where he provides various tools and resources and different pre-built functions and code in order to teach myself how to do most of this here. Moving along, this is the main function for the R2R from the given project. I've included some headers that may or may not have been in the original. I'm not sure at this point. Sort of mold clay into the point where you don't remember how it started. I have some basic functions here defined, some leftover code from that project, but essentially I have some more values here to keep track of different things. I'm not sure if I'm using the I anymore. A key value and a previous value, both from the previous project, the PLL, DAC initialization, keypad init, switch init, and disable interrupts. I believe I moved my DAC to the sound file, so it's no longer located here on the left. Moving along, so this is the section that handles the different output modes using switch 1 to change between them. Switch 1's the onboard switch on the TM4C. I have set it up using a switch mode. Good advice from a fellow classmate, basically saying that it was like a good way to set up like the different modes, and I agreed. So I went forward with that. I have the disable interrupts and enable interrupts around the outside of my sound init. My sound init function calls right here. It basically takes a char and a period and establishes, based on the waveform given, either the triangle sign or square wave output. Then moving back into case 2, case 1 does the sine wave by passing an S. Triangle wave does a T, and square wave does an R, but they all form function very similar, outputting the same style of information. And then once the button has been pressed on the board enough to get to case 4, which I believe I had it starting on 0 or 1, I don't remember. So it's a couple of button presses gets you to case 4, which then detects the key input. Now, unfortunately, I was not able to get the 4x4 matrix to work with both rows and columns, so it's currently set up in a way that I could teach myself how to use it, which is to just have it only detect columns. So if any button's pressed in a column, it detects that. So I'm limited to 4 notes currently, but plan to further research this and hopefully get that thing running. Maybe a classmate can show me how to do it, but unfortunately was never shown how to work with a 4x4, and having a lot of trouble with that one. But anyway, so if column 1's detected 5, 9, or 13, it will be determined the values by each case. So when the keypad detects an input, it will give the key value one of these, and then based on the values, returning back to get frequency, based on those values, the different cases, the different frequency count values for CEGB will be called, which will give me my scale, and that'll be done down here. This is also a leftover section from the R2R file, slightly modified, but the sound get frequency takes the key value, gets the frequency number, and then does what it did up here before, where it takes the value and a char, and then it passes a sine jar and then that frequency from that table lookup, which determines the sound as long as the button is pressed. If the button is released, this line of code here will stop the sound, otherwise it'll just keep going. And then this was left over, just creating a remove switch bounce, helping to delay the the button pressing the switch, sort of a brute force way of solving debouncing, but it seems to work okay. And then default mode 0, so if the counter goes above 4, it will reset back to 0. Okay, yeah, so, and I started in 4 for piano mode. Let's see, alright, so I think that covers all of the code. Oh yeah, switch was left over from the default. I may have changed a couple of things in here, I'm not sure. Oh yeah, and then these are the different outputs, DAC outs with the different chars. And the DAC out just takes the data and puts it to the board. Oh, and then let's go ahead and take a look at the board. So the board is set up over here. I have my 8 ohm speaker. I have my volume knob, which I've left in one spot because I like the volume at that level. It's not super loud. And then this is my R2R DAC with my 6-bit pins, which are connected to the board. And then these 3 wires here are connected to my variable resistor here. And then a capacitor for smoothing out the voltages within the LM386, which amplifies the sound out to the speaker. And then, connecting the board across grounds, all that simple good stuff. And then this bad boy here is my keypad, which, oh yeah, it's set up in keyboard mode currently, so you should be able to hear, let me see, when did I set it up to? Can't remember. It was... oh yeah, C, E, G, B. A little tone deaf, so I gotta look these things up. So this one's C, E, G, B. Alright, one more time. C, E, G, and B. Alright, and then pressing the switch on the board will take you to my ugly sine wave. But that's the sine wave. And then I have the triangle wave. And then we have the square wave. And let's go ahead and turn that off. Alright, so turning that off with the volume will complete the demo. I believe that was the code and the piano. And thank you very much.